Hi guys, these are your notes for section 10.1, and today we're going to start a little trigonometry unit, and this one is on trigonometric functions. Today we're going to apply the sine, cosine, and tangent ratios to find the lengths of sides of certain right triangles. Today what we're talking about is only right triangles. The rules I'm going to talk to you about today can only be used on right triangles, and we're going to be finding missing lengths of those right triangles. Okay, first of all, I don't know if anybody's ever told you a little bit of math history. There's something called the Trig tribe. And the Trig tribe, they lived in what all Indians / Native Americans lived in. They lived in teepees. And their teepees were special. They were right triangle teepees. So there's a picture of one. It was many, many, many years ago. And the chief of the Trig tribe's name was Sokotoa. And there's like a lot of stories and legends about the tribe doing lots of chants, Sokotoa, Sokotoa, Sokotoa. But anyway, they built so many of these teepees. Obviously, whenever you're a big Indian tribe, you have to build lots of housing. They discovered, and this is where Chief Sokotoa got his name, that there were certain qualities that right triangles had, and they were actually the founders of trigonometry. And that's how it got its name, trigonometry. And Chief Sokotoa's name has a lot to do with this trigonometry, so you do need to memorize his name, and you'll discover what it has to do like on the next slide. Okay, so that's just a little bit of math history that is completely made up. So please don't act like that's real. Okay, basically what we're going to be dealing with today is all right triangles that have a certain degree measure. For example, a 30, 60, 90 or a 45, 45, 90. They have the same ratio of side lengths. You guys talked about this in geometry when you were figuring out missing sides of 30, 60, 90 triangles or 45, 45, 90 triangles. The same is true for every degree combination. Okay? So basically they figured out what this ratio is, and we used to have something called trig tables, which I'm going to show you on the next page, but now all those values are stored into calculators. But this is the way that we have that ratio of the lengths of the sides in a place where you can access it more easily. Okay? A lot of times when you're dealing with trigonometry, we use a Greek letter called theta, and it looks kind of like this. Some people write it like this. Some people write it like this. I don't care what you do. Okay, so let's talk about trig table. Here it is. Basically, they're saying if you have, well, is 30 on here? Oh, I just did the top half. 30 and 60 are not on there. 45 is also not on there. Okay, I wish those ones that you guys knew were already up there. But this is the ratio that they're talking about. And so let's go to 46, which is close to 45. This radian measure we're not going to be really dealing with today. These are the ones we're going to be dealing with: sine, cosine, and tangent. Sine is the ratio of two sides, and that proportion will be this. And what I mean by that proportion, keep in mind that like 10 over 8, if that was the ratio of the sides, it would be the same thing as 5 over 4. Okay, so this is just the simplified version of the ratio of sides. Cosine is another ratio, and tangent is another ratio. So what are these ratios that I'm talking about? Well, sine, and we're going to write this on the next page. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay? Remember the chief's name? That's a J. Pretend that's a J. Sokotoa, look. So, opposite over hypotenuse. Adjacent over hypotenuse. Toa, opposite over adjacent. So when I'm looking at a angle of 46 degrees, if I go to the side opposite over it, and I put it over the hypotenuse, this will be the simplified ratio I get. Okay, we're going to see some examples. This should make more sense. This trig table you will probably never again use or see in your life because everybody uses calculators on these problems. All these values are stored into your calculator. But back in the days of Mrs. Thurston, she would have had to look these values up. Actually, I had to look them up too, but then I got a scientific calculator. Okay, you need to keep this in mind. When I have sine of an angle, so if I have something written down like sine, and we do write sin, even though it is sine, it's abbreviation. I don't know what it helps to get rid of one letter. Sine of 60 is just a number. That equals a number. Actually, I don't have my calculator with me, or I would tell you what the number, oh, I do. Sine of 60, I'm going to change it to degree mode. We're going to talk about modes of calculators later too. Sine of 60 is 0.866, and it goes on for more digits than that. It's just a number, so you treat it as such. When you see this, don't think that sine times 60. There's no such thing as just sine. Sine is telling you what ratio to get of the 60-degree angle. Okay? Today, the angle theta has to be between 0 and 90. Why? Because I told you we're only talking about right triangles. One of the angles in a right triangle is 90. We're only concerned about this angle, and it definitely has to be less than 90. Otherwise, we don't have a triangle. I want everybody to turn your calculator in degree mode today because all of your homework problems will be in degrees. On the 84s, you're just going to hit mode and then make sure you're in degree mode. On the Inspires, I'm not quite so sure. It's probably somewhere in settings. I can help you with that if you have questions. Here are those ratios I'm talking about. Okay? So, it says the sine of theta. Here is the angle we're looking at. When we're talking about these trig functions, I'm always going to ask you to mark your angle like I just did, so I know where I'm talking about. Sine is, this is what I write, sine of the angle is opposite over hypotenuse. Basically what they're saying is, this is opposite. If I have a length for a side here, which I don't know what it is, but if I have a length of a side, let's say it was 10, I'm just making it up, and the hypotenuse was 23. Then the sine of the angle would be 10 over 23. We could figure out what that angle is if I change that to a decimal, and I go back and look on sine looking for that decimal until I find it. And then that would be the degrees. Okay? You're not going to have to use the table. I'm going to teach you a way to do that with your calculator. Okay? Cosine of the angle is, let's say that's 18. Just making these up. Adjacent over hypotenuse. Adjacent means next to, so I go to my angle. What is next to it? Oh, it's 18. Hypotenuse still 23. Again, 18 over 23. Get a decimal version, go to the cosine column, I can figure it out. Tangent is opposite over adjacent. Opposite would be 10, adjacent would be 18, so that's 10 over 18. Okay? Keep in mind that sine and cosine will always be less than 1. Because, why? Well, the hypotenuse is always going to be your biggest number on the triangle. So, that as a result, you're dealing with numbers less than 1. Tangent could be less than 1 like it is here. Could be more than 1 if those sides happen to be reversed. So, this one is the one that could be bigger than 1. Okay? If you get bigger than 1 though on sine or cosine, you're messing something up. But not necessarily. Alright, I love trig. This is fun. Okay. Use the flagpole mentioned on page 662. Find the distance from point A to the top of the flagpole. Oh, okay. This is not even your book. I had it all ready to go. Wrong book. Hold on. Okay, I found it. So what was the question? They said use the flagpole, which I found it. They want to find the distance from A to the top of the flagpole. Where is A? A is here. It's not labeled. I got to annotate over. Okay, this is A. Top of the flagpole is B. Okay, so actually what we're kind of looking for here is which side is this? From A this, they want this distance. That would be the hypotenuse. Okay. What did they give me? Well, they gave me this angle. They gave me this 39-degree angle. Then what else did they give me? They gave me this side. So let's think about this. They gave me an angle and they gave me a side. Which side is this? Adjacent or hypotenuse? This happens to be adjacent. So then you go back to SOHCAHTOA's name and you say, well, what are they giving me? They gave me an angle, which is great, and they gave me an A and an H. Which one of these has the A and H combination? Ka, which is cosine. It's always cosine of the angle is adjacent over hypotenuse. Okay, so what do I have here? I have cosine of 39 equals adjacent, which is 22, over the hypotenuse, which I don't know what that is. Remember, cosine of 39 is just a number, so put it over 1. We have two fractions equal to each other, so we can cross multiply. 1 times 22 is 22, or find the cross products. X cosine 39. Cosine of 39 is just a number. Okay, so you can divide both sides by cosine of 39. I know I'm kind of running out of space here. And we're going to type that in our calculator. When we type in our calculator, it'll be 22 divided by cosine 39. Enter. And I get, for x, 28.31. So the hypotenuse was about 28.31. Go back to my chart here. My flip chart, maybe. And we got 28.31. They want us to use the Pythagorean theorem to check it. You can use your Pythagorean theorem a lot on these to check. If I look here, they should have already found one of the sides. Did they? Maybe not. But we could do trig again to find out how tall the flagpole is. In which case you could do Pythagorean theorem to make sure it works out. Remember, Pythagorean theorem is a squared plus b squared equals c squared. Oh yeah, so you find the height right here. They said the height was about 18 feet. So they said the height was 18. So I have 18 squared plus what was the other distance? 22 squared. And we're going to see if that equals about, because remember we are rounding here, 28 squared. 18 squared plus 22 squared. I got 808. Does that equal about 28 squared? 784, it's pretty close. If I kept the decimals, it would have been the same. Okay, here's another example. Oh, I had the flagpole right there. Darn it. Oh, well. In example 2, what is the horizontal distance from point H to I? So here we're figuring out H to I. Mark your angle. Here's my angle. What am I looking for? I'm looking for this side. What do I know? Well, this is an opposite. That's given to me. This is now an adjacent, which is what I'm looking for. I have an O and an A. Look at his name. SOHCAHTOA. You need to memorize that. And I'm going to be using tangent here. So, tangent of the angle equals opposite over adjacent. Tangent of the angle is 16.7. That's just a number. Is opposite, which is 490, over adjacent, which is x. We don't know. Put it over 1. Cross products should be equal. 490 equals x. Tangent of 16.7. 16.7 is just a number. Divide both sides by 16.7. Excuse me, by tangent of 16.7. That's a way different answer. Don't make the mistake I just wrote down. 490 divided by tangent of 16.7. And we get way big number. 1,633 meters. This should make sense. This is an itty-bitty angle. That itty-bitty angle, and this is still 490 degrees. It's going to be pretty far out. Okay? You could do Pythagorean theorem to figure out the hypotenuse if it makes you feel better, but it's not necessary if they don't ask. Okay? When you have an angle of elevation, they will tell you that sometimes in your worksheet. It is from eyesight. So they were asking you how high the sun was. which they would never ask. But they might, or how high the cloud is. I guess that's maybe what they're looking for. Keep in mind, once you figure out what this height is, you are going to have to factor in the height to the eye level also, or you're going to be a little off. Okay? Angle of elevation will be this angle from eyesight to whatever you're looking at. Another thing you're going to have to keep in mind is we're going to draw auxiliary lines to create right triangles. Sometimes you're not given a right triangle, but we can draw one in. So here, they said each side in the regular polygon viola is 7.8 centimeters. Find the length of the diagonal, VO. So what we can do is, regular polygons, I don't know if you remember this. Oh, that's too bad. Interior angles is n minus 2 times 180. Okay, that's for all of them. So here it'd be 3 times 180, which is 540. You divide that by 5, and the whole angle here is 108. So each little one would be 54. You could then use trig. That's an opposite. That's a hypotenuse. Sine of 54 is x, what we're looking for, over the hypotenuse, which is 7.8. You can solve that easy enough for x. I get x to be about 6.3. But that's just this little piece here. Keep in mind there are 2, so you multiply that by 2, and the whole diagonal is about 12.62. Okay, so that's another thing you can do. Here's one more example. Regular pentagon. Each side is 50. Is that the same one I did? It wasn't 15.4 before. It was 7.8. But the process is going to be the same. They want the length of the diagonal B, C, D, E. They want the length of the diagonal A to C, so you're going to do the same process on this one. Alright, the last thing you need to know, and I have students in the room right now, is that those ratios, some of them you already know from your geometry. You probably have blocked them from your memory. But here are those special ratios that you do already know. If you have a 60-degree angle, these are some ratios that you've already been accustomed with. Sine of 30 is 1/2. Sine of 60 is square root of 3 over 2. Sine of 45 is square root of 2 over 2, and so on. You might want to put those in your notes. They are so mature. Here's your homework assignment. It will be fun. We will do it tomorrow. And there's a pigeon calling. Okay.